Today we're talking about Pythagorean Theorem, and with the Pythagorean Theorem we are talking about right triangles. So notice it says in a right triangle the sides that are adjacent to the right triangle are called the legs. Adjacent means next to. So when you find your right angle, remember the box there indicates that that is a 90-degree angle, a right angle. So the two that are next to it, meaning the two that make up this right angle, those are called the legs. Okay? Then the one that is opposite or straight across is called the hypotenuse. The hypotenuse is always the longest side of a right triangle. Okay, so there's two ways to kind of think about it. It's opposite the right angle and it's the longest side here. Says the Pythagorean theorem describes the relationship between the lengths of legs of the hypotenuse. This theorem is true for any right triangle. If a triangle is a right triangle, then the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. And I posted on Google Classroom some Google Slides with some videos that kind of maybe can help make more sense of this. We watch these in class. You don't have to take the time to watch these, but it kind of explains where we get this form or this equation of a squared plus b squared equals c squared. And it's talking about the sides here of the triangle. If I was to take this side and square it, this would become a square. Same thing here. If I would square it, this would be an a by a, or a squared. This would be a b by b, or b squared. And then this would be c by c, or c squared. And in the videos they showed how if you break this up and put it with this one, you end up getting the exact size of this one. And they show that in the video. It might make more sense after watching it. So that's why this equation works. If you're missing a side length, like the hypotenuse, I can take one of my side lengths and square it, add my other side length squared, and it equals this side length squared. Okay? So, like in this example, if A is 3 and B is 4, we would solve for C. So the way you would walk through this problem is you'd say, okay, A squared, this side length is 3, so 3 squared plus this side length is 4. 4 squared equals, we don't know that side, so C squared. Well, 3 squared, remember that's making this 3 by 3, so that would have an area of 9. 3 squared is 9. Don't forget, 3 squared, that really means 3 times 3, or on your calculator, you would type 3 caret button 2 is 9. Then 4 times 4, or 4 squared, is 16 equals c squared. Well, 9 plus 16, that gives me 25. And we talked about this a little earlier in the year. To cancel out squaring, the opposite of squaring is taking the square root. So I would take the square root of both sides, because what I do to one side, I have to do to the other. My square and my square root cancel out, and that's just c. The square root of 25, remember how to do that? You would type 2, your second button, and then your caret button. So this is taking the square root, not the cubed root. That would be a 3 in front. So square root of 25, and that's 5, because 5 times 5 gives me 25. So that missing side length then would be 5. Okay? And it shows an example here Now, I don't know why they write it the opposite way. Typically, you always see it a squared plus b squared equals c squared. This is the same thing. They just put the c squared on the other side. So it's still equal to each other the same way. They just showed it a little bit different. And again, this is the way you will mostly see it, not written that way. It doesn't matter which one you choose as your a and b. So 12 squared plus 16 squared equals c squared. And 12 times 12 is 144. 16 times 16 is 256. I would add those up, simplify that side, and when I do that I get 400 equals c squared. Again, the opposite of squaring is taking the square root. So to cancel that out and just get c, I have to take the square root. What I do to one side, I have to do to the other. And when I type that in, 2 second caret button, so the square root of 400 is 20. Since I know that they're talking about feet, I would put 20 feet. Sometimes it's not the hypotenuse you're looking for or the longest side length, it's one of the legs. Okay? And so this is an example of that. They have their a squared plus b squared equals c squared. And I don't know a. That would make this b, because remember, the opposite side has to be the hypotenuse. The hypotenuse is always the longest side, and that's always your c here. So b has to be 10, so 10 squared equals c is 14, so 14 squared. A squared plus 10 squared is 100. 14 squared is 196. I have to try to solve this. So I will take the square root, but I'm not going to do that first. I'm going to take this 100 and try to get rid of it. You always try to get rid of your constant first. Your constant is your number by itself. So a squared is equal to, this is 96. Now I'm going to try to get rid of that squared by doing the square root on both sides. And sometimes it won't come out to be an exact number. Remember, 2 second caret button. This is not a, 96 is not a perfect square, meaning it's not going to come out to be a whole number. So on something like this, you would just round to the nearest tenth. So 9.8 centimeters. Okay? You can go ahead and try these, and the answers are posted on Google Classroom, so if you would like to try those as like got it problems and check to see if you did them correctly, you can look there. They look just like the first two examples that we did. So this is like example 1, this one is like example 2. Then we have this part. It says converse of Pythagorean theorem. The Pythagorean theorem is written in if-then form. If you reverse the statement after if and then, you have formed the converse of the Pythagorean theorem. So what we've looked at so far is if you start with a right triangle. We've been talking about right triangles. Pythagorean theorem only works for right triangles, not acute triangles, not obtuse triangles. So if you're working with a right triangle, then we know a squared plus b squared equals c squared. The converse of that would be, well, if a squared plus b squared does equal c squared, then you know it has to be a right triangle. Okay? You can use the converse to determine whether a triangle is a right triangle. So for example, it says the measures of 3 sides of a triangle are given. Determine whether each triangle is a right triangle. So we have 9, 12, and 15. So they have a triangle. We don't know what it looks like. It could be a right triangle and look like this, and it would just be like 9, 12, and 15. I would know 15 would have to be my hypotenuse because it's the longest side. So like right here, 12, that's my longest. I would have to put that in as C for my hypotenuse. The legs, it doesn't matter which one you put in for A and B. It works the same because if I wrote 9 squared plus 12 squared or 12 squared plus 9 squared, either way it's this exact same answer that we're going to get at the end. Okay? So we did our A is 9 squared plus our B is 12 squared equals our C 15 squared. So you're putting it in with no variables. You're not solving for a variable on this one. You're just seeing, does this actually work out? Well, 9 squared, that's going to be 81, plus 12 squared, that's 144, and 15 squared is 225. Then when you add 81 plus 144, you get 225. Since they come out equal to each other, this side is 225 and this side is 225, you know that a squared plus b squared equals c squared works. So that means it has to be a right triangle. On this one, when you set it up, 6 squared plus 7 squared equals 12 squared. 6 squared is 36 plus 7 squared is 49 equals 12 squared is 144. When you add these up, you only get 85. Well, 85 is not equal to 144. So that means the a squared plus b squared equals c squared doesn't work. Since it doesn't work, it cannot be a right triangle. It could still form a triangle. It's just not going to be a right triangle. Okay? Again, these two examples look just like the example 4 that we went over, both different parts, A and B. If you'd like to try that one, you can work through them, and then the answers are on Google Classroom. The last couple, I'm just going to show you what the answers would look like, and if you have questions, you can always email me. So again, if you wanted to, you could pause the video, try some of these if you think you're going to struggle with something, and then look at the answers here. But on number 3, I put in one of my legs squared plus my other leg squared equals my hypotenuse squared. 15 squared is 225. 20 squared is 400 equals c squared. I take 225 plus 400, and that is 625. Then I need to take the square root on both sides in order to cancel out this squared. That gives me c is equal to 25. On the next one, this time they gave us the hypotenuse. We're missing one of the legs. So 8 squared plus b squared equals c squared. A is 8. C is 17. 8 squared is 64. 17 squared is 289. We don't know this one yet. To try to get b by itself, before taking the square root, we have to get rid of the 64. So we subtract 64 on both sides, and that gives me b squared, because this cancels, b squared is equal to 225. I would take the square root to cancel out my squared, and the square root of 225, again, if you forgot, that means you're taking 2, second caret button, and then type in your number, and then you get 15. The next ones are deciding whether this triangle is a right triangle or not. So 5 squared plus 7 squared equals 8 squared. 8 has to be in the C because it's the biggest one. Okay? So 5 squared is 25, 7 squared is 49, 8 squared is 64. 25 plus 49 is 74. That is not equal to 64. So no, this is not a right triangle. The next one, it's not meant to confuse you on this. A is 11, so 11 squared. B is saying it's the square root of 55. So I have to take my B value and square it. C is the square root of 144, so I have to take my C value and square it. So 11 squared is 121. 55 squared, well, I'm sorry, the square root of 55 squared, well, remember, squaring something and the square root cancel each other out, so that would just be 55. Same thing here, the square root of 177 squared, square and square root cancel each other out, just like they did up here. When I had b was squared and I was taking the square root, they cancel each other out and it was just b. So that's what they're doing here. That's just 177. 121 plus 55 is 176. That is not the same. Even though they're very close, they are not equal. That would not be a right triangle. The last story problem's kind of tricky. You had to draw a picture probably to understand it. You wouldn't have to, but it helps a lot, I guess. Kendra's flying a kite. The length of the kite string here is 55 feet. She is 40 feet away from beneath the kite. About how high is the kite? So this would be my right angle, which means this is my hypotenuse. Okay, so 40 squared plus we don't know squared equals 55 squared. And again, you could put the variable in for A or for B. It really doesn't matter. Okay, so 40 squared is 1,600. 55 squared is 3,025. I get rid of this constant so that I have b squared by itself. And then I need to get rid of the squared. So I take the square root of both sides. And when I round, that would be 37.7 feet. So about how high is a kite? About 37.7. If you have any questions, let me know, and then don't forget to finish your homework.